Hi, my name is Hope Frost, and on behalf of SBK Healthcare, I'm delighted to welcome you to this recording of our webinar on developments in closed loop therapy, sponsored by Advanced Therapeutics UK Limited. To find out more about our other online and face-to-face events, please do visit our website at www.diabetes-nnf.co.uk. If you like this recorded webinar, please remember to like and subscribe to our YouTube channel so that you don't miss any new content that we upload.
Good afternoon. Thank you very much for attending the meeting. My name is Karen Smith and I'm the APS Hybrid Closed Loop Manager for Advanced Therapeutics. What we're going to cover today is just a brief overview of the Danai insulin pump, some of the features and benefits of the pump, the benefits of having an interoperable pump within hybrid closed loop, and then any support that we offer and that you need from AT UK. So just a brief history on Sul, who are the manufacturers of the Danai pump. They have been developing insulin pumps since 1979. So they've got a long history of pump development. And the aim was always to have a pump that would form part of an interoperable artificial pancreas system. So as you can see, we've been working with various algorithm developers since about 2011 to get to where we are now with the Danai pump. So the reason people choose the Danai, if we speak to patients, it's for discretion. So the pump is fully operable via either a handset or a mobile phone device. So a lot of patients like the fact that they don't have to get their pump out to deliver boluses. They can do everything via their phones or a handset. It's also for accuracy of delivery. So the Danai pump has a linking screw, which enables a real accurate rate of delivery, and also for the interoperability. So it can be used with different hybrid closed loop systems as they come to market and get their license. So the benefits of Danai, we also have our own app, which is Any Danai app. This acts as a remote control for the pump, where you can give a bolus, you can set temporary basal rates, and you can change all of the settings on the pump, including your carb to insulin ratio and insulin sensitivity factor. It is compatible currently with CAM APS in the UK and has been used in most of their clinical trials since about 2012. And then future systems we hope to be compatible with is, of course, Diabeloop, and then others as they come to market, so Tidepool, any Diabeloop, etc. The features of the pump is that it has been designed to be used as the foundation for APS systems. It has a low energy Bluetooth, which is version 5. So that is a real fast and reliable data handling. The Any Danai app, which is a remote control, is compatible with both Android and iOS. It's very, very small and lightweight, and you can have a choice of insulin in the pump, and it has a very large 300 unit reservoir. You can part fill the reservoir for sort of children or people who have less insulin requirements, but for those people sort of in pregnancy or those hormonal teenagers, they can fill to 300 units. The bolus increments are 0.05 units is the minimum, and the basal increments start at 0.04 but increase at 0.01 per hour. And it can be really flexible. So we've got 24-hour carb to insulin ratio and correction factors. So you can really fine tune those carb to insulin ratios, which is a real benefit when it comes to sort of pediatrics and lunchtime snacks and things. The pump can be used as a standalone, so you don't need to operate it with a mobile app or a handset. And we can remotely update the operating system on the pump. So Danai versus the Danai RS, it now has version 5 Bluetooth, which enables it to send more data faster and over a longer distance. All of this together also ensures improved connectivity to the phone, but also uses less energy, so the battery does last longer. It also has a variable speed delivery. So you can have 5 minutes a unit down to 1 minute unit, which really does help with the absorption of insulin via the cannula. As I said, it can be used as a standalone, so there's no need for a phone and handset. And it does have a built-in bolus calculator. So if I had a young girl a few weeks ago whose phone broke at school and the team were able to deliver a bolus via the bolus calculator that is integrated within the pump. It also uses standard AAA batteries, which are easily accessible. So the Danai is also one of the most accurate pumps on the market currently in the UK. Bolus delivery of 0.05 units and an error rate of either plus or minus 4%, and the basal again with 0.04 and the error rate of plus or minus 4%. So this is a real benefit when dealing with hybrid closed loop, is the accuracy of delivery via the pump. It is open source. So what we're really proud of is that it is compatible with existing hybrid closed loops on the UK market, but we're really looking forward to introducing choice to patients by being compatible with other hybrid closed loops as they're developed and launched in the UK. The Danai, we believe, is future-proof, so they get a pump today and we can remotely update the firmware on the pump, therefore it makes the pump future-proof. We've got a choice of 4 cannulas, which is great for patient choice. We have a Danai Inset 2, which is a Teflon cannula, a soft release O, again, a Teflon cannula in 6 and 9 mil. We have the Easy Release, which is a 4.5 mil cannula, so it's absolutely tiny and great for children. And then we also have the Soft Release Micro. The training and support that we offer is we have online training videos, and we are constantly updating and adding more online training videos for the feedback we get as to what the patient needs are. We're more than happy to do either face-to-face or virtual pump starts, and we offer pre-pump pump starts and often follow-up. So I often will do some cannula changes or do some conversations with the team about different lifestyle events that are happening to help people get the best out of their system that they're on. We offer demo pumps and samples for centres, and we also offer training on hybrid closed loop, any Danai and any Dana, for both patients and healthcare professionals. We do sponsor the Diabetes Technology Network, and we're more than happy to come along to any regional network forums that you have so that we can show you the pump and talk about the hybrid closed loop systems. And we offer ongoing support, so we try and tailor our offering to each centre as to what they feel that their needs are. So in summary, the Danai is at the moment the only open source pump on the market, and it gives patients a real choice for different types of hybrid closed loop systems. With the nice health guidance going into consultation for hybrid closed loop, we think that patient choice will become more and more important. So we'll get to a situation where they can pick which pump is suitable for them, which hybrid closed loop is suitable for them, and then the CGM as well. And that's sort of the aim game in the next 18 months. And I think in the UK, we're really far ahead with regards to this technology. So that's it from me. If you want to reach out and have conversations on the technologies that we have, please do. Either contact myself on the email on screen now or Advanced Therapeutics Direct, and they'll pass you through to your relevant contact. And that is it. So thank you very much. What I'm going to do now is I'm going to hand you over to Diabeloop. We have Erik Huneker, who is the CEO, and we also have Professor Pierre Benhamou, who is the clinical director at Diabeloop. So thank you very much for your time.
Thank you very much, Karen. I'm going to start with sharing my screen, and let me know if you can see the slides. Is it okay for you?
Yes, we can see them.
Okay, great. So I'm happy to start with an update about closed loop therapy. So my name is Pierre-Benhamou, and I'm a diabetologist dealing with adult patients with type 1 diabetes. And let's start with the current achievements with closed loop therapy. And we as human beings are happy to have currently 5 commercially available closed loop systems as far as I know. And these are summarized in this slide, where you can see that 3 are coming from the US, 1 is British, and 1 is French. And I summarize the key pivotal trial publications that helped to bring these systems to the market. Regarding the overall picture of these pivotal trials, this slide show you the 5 main results. And please be aware that all these trials did not start on the same baseline time in range, which may explain some of the differences between the results. Overall, the results are pretty similar, despite different algorithm, but Erik will talk more about these differences. And please be also aware that the design of these trials were not the same, as some of the systems were tested only in a before and after design, where other systems did go through randomized controlled trials. I think that more importantly, the real-life data are really showing what we can expect from a system. And there have been 3 reports of real-life data with 3 different systems in the past year. And I will start with the one that I know the most. It's the one that come with the Diabeloop DBLHU system that was launched in Europe about 18 months ago. And we have some data with 3,700 patients in Germany. And this slide can show you that we now can achieve the recommended standard of care figures. As you can see that 72%, the time in range, the time in optimal range is 72%. The time below range is almost null in the majority of patients. And the glucose management index reached in this cohort is exactly 7%. So these are very pleasant results. And we also can see the proportion of patients that can reach the different criteria for optimal glucose control. And we are happy to say that hypoglycemia seems to disappear with this system, and nearly half of the patients are able to reach all 3 criteria, whereas in open loop, the majority of surveys that have been done in European countries shows that only 1/4 of patients could achieve this result in open loop. What is interesting is to see that the outcome can be seen already after 1 week or a couple of weeks. And these results remain pretty stable for at least 1 year and can carry on after 1 year. And this result will be published very soon. And we can compare these results with what has been reported with other systems, such as the Medtronic system. And you can see that the figures are pretty similar in terms of time in range. Although the hypoglycemia rate was a little bit higher in this system. And another publication came at the same time with the other American system, the Control-IQ system. And once again, the figure in terms of time in range are pretty similar than the one observed with the 2 other systems that I've showed you. So it may be difficult for a healthcare professional to choose between these different systems. And what about the regulatory requirements? So all the systems are CE marked for adult patients. only 2 systems are marked for very young children, and only one is CE marked for pregnancy. Now, if we look at the recommendation from an expert consensus that was published last fall, well, it's obvious that closed loop is strongly recommended for adult, teens, and school-age children with type 1 diabetes. They are also now recommended for more elderly people as well as preschool children, because some publications were done very recently in these 2 populations. And we can consider also using this closed loop systems in other populations with specific risk. I mean, patients with severe hypos or hypo unawareness. And Diabeloop comes with special algorithms that can address this population. I will talk about pregnancy at the end of my presentation. And the patients with some comorbidities have to be studied, as well as patients with type 2 diabetes. Regarding the different settings of these 5 systems, I will insist on the fact that the target glucose is not the same between these 5 systems, and it can be customized only with 3 levels with the Medtronic, 100, 110, and 120. It can be customized with CAM-APS and Diabeloop with a large range. It's fixed with Tandem Control IQ, and it can be customized with Omnipod 5. So this can explain why it may be more relevant to use some systems into peculiar situations, I mean pregnancy and severely unstable diabetes, when you want to really tune the systems according to the specific physiology of your patients and specific requirements of your patients. So that I try to summarize some criteria of choice. And I would say that when you have a patient that does not want too many settings and too many actions on the system, then Medtronic system could be interesting. But on the other hand, when you want to specifically tune your systems and be more flexible according to the way of life of your patients, then Diabeloop and CAM-APS could be more interesting in this regards. And another point, criteria of choice is the sensor that is coupled with the systems, and the Dexcom sensor may probably is more easily used than the Medtronic Enlight sensor or widen sensor. Another criteria of choice is a population, and obviously so far with very young children you only have a choice with the 2 systems that came through trials, the CAM-APS with a randomized trials in very young children in the Omnipod 5, but it was only a single arm study. Now I will hand over to Erik regarding the algorithm. So Erik, if you want to take the lead, I will pass your slide.
Sure. One thing also before I jump over that is that we have now over 11,000 patients in Europe, mostly with the Roche Insight pump. And one thing we've observed is an extremely low dropout rate. Over 99% of patients continue using the system after 9 months. So 1% dropout rate is very, very low and way below the standards of what has been observed with other systems. And that is due both to the low hypo and the fairly low number of, you don't need to interact with the system a lot. And also due to one thing that I'll go with on how the system's set up a little later on. So the way the system is set up is that you have a first module, which is a safety module, that's going to evaluate the hypoglycemia risk. Now, this is done automatically, of course, and then if there is a hypoglycemia risk, the system will first cut off the insulin and then if that is not enough, recommend a dose of rescue carb to the patient. And this is obviously not a machine learning complex algorithm or artificial intelligence or anything like that. If there's no safety risk, then the algorithm is going to look at a machine learning algorithm that's going to be looking at the patient through what we call physiological frameworks. In other words, it's going to be self-learning the patient's physiology and then doing a glycemia prediction from there. Now, as we all know, sometimes there are unusual cases, sudden drops, sudden increases that really cannot be explained for a physiological reason. Then we have a patented technology that's going to be supervising the machine learning algorithm. And then we have, and hands it over to an expert system. An expert system takes really what a doctor, a diabetologist, or an expert patient would do in any given situation and translates that into a decision matrix and then into calculations. So that is a more robust general system, even though it really doesn't work as well on average than the machine learning advanced algorithm. Finally, we have self-learning, auto-learning on a number of parameters, be it basal profile needs, be it meal ratios at breakfast, lunch, and dinner, etc. And those self-learnings are going to be looking at weeks worth of data to determine patterns for each patient, and then re-inject these patients into the short-term algorithm, both the machine learning and the expert system. So that's kind of how the overall algorithm works. The system's designed to be simple to use, meaning you really don't need to have an advanced degree in diabetology as a patient or as a doctor to use it. It's really simple to use. It is still personalized, meaning that you can set the target, you can set the overall aggressiveness of the algorithm, and it is interoperable. Currently, it resides on a smartphone, a dedicated handheld, although sometime by the end of this year, early next year, it will be available as an app as well. Now, what's interesting is that it only requires weight, total daily dose, and typical meals. When I say typical meals, it's approximately, is this particular patient eating small, 20 grams of carbs at breakfast, or is he eating large meals? And the safety basal rate, also the safety basal rate is not used by the algorithm. It's just as a backup in case, for example, the sensor has an issue or something like that. Now, with, can you hold just 1 second, please, Pierre? With the weight, total daily dose, and typical meals, that is really enough for the algorithm to work. And from there on, you have both the short-term self-learning and the long-term self-learning that kicks off. And that's really interesting because, of course, many patients are taught in functional insulin therapy, where they have their compensation factors locked in, their meal ratios locked in, their basal profile locked in. In this particular case, you don't need it, which means that there have been quite a few patients that have transitioned directly from MDI over to the system without needing to calibrate their basal profile or anything like that. And that may be one of the explanations why, compared to other systems, our baseline, so where do people start off from, seems to be higher, higher in terms of HbA1c, lower in terms of time in range than other systems, because it is simpler to start off with this system. And that's what we've observed in Germany and in other countries. The personalization, you can set the target, you can set the hypo threshold, because obviously for certain patients are either more comfortable, or as a medical professional, you want to set the targets lower or higher depending on this patient's personal profile. You can set it at 70, 80, 90 milligrams as far as the hypo threshold. And you can set the aggressiveness. And this is a very simple slider. It starts at 100%. And if you want more aggressive, you go to 110%, 120%. And that's kind of, again, an easy way to set the algorithm's overall tendencies without having to have an advanced training in diabetology, which really helps a lot in quite a few for quite a few types of patients, or even certain care centers, which aren't, I mean, there's different types of training on how people train on diabetology setups. We talked about the adjustable targeting aggressiveness. There's a confidentiality mode. Now that's interesting because the data is uploaded to Euroloops, which is our data visualization platform. From there on, the patient can choose to share his or her data with anyone, be it, of course, a medical professional, doctor or nurse, or a caregiver, a close one. But sometimes certain patients will only do that, but they want to have control over the data, either because they want to be off for a weekend and just not care, and they don't want to necessarily share it with their doctors, or certain types of other activities. And that's actually, there's a minority of patients that ask for this, but the ones that do really, really want this. Zen mode, which temporarily increases the target glucose in case you have a specific, I don't know, a specific meeting or you've eaten in a special way, or you are going on vacation and you drive and you've gotten up early and the kids are in the back, etc., and you don't want to be disturbed. And then you have exercise mode, which is going to be changing both the insulin board before the sports, but also tuning the insulin needs and the reaction for up to 18 hours after the sports. And that has been calibrated with clinical trials as well. Now, interoperability. What does it mean? It means that the DBLHU system, now it's not currently available with every single one of these, but it will be within the next, I want to say 6 to 9 months with every single one of these pumps. Now the Kaleido patch-like pump, which is with a small tubing, Accucheck Inside that I think most of you know, the Danai that we just talked about, the Medisafe With, which is a patch pump made by a Japanese company called Terumo, which is probably not well known. We quite like it. It's slightly longer than the Omnipod, but it's still, it's relatively flat. Yeah, it's something that we appreciate. We appreciate that pump quite a bit. And then the EOFlow, which is a patch pump that resembles the Omnipod quite a bit from a physical and usability perspective. And that also gives the patient a choice, because many of these pumps have different types of cannulas. And you know, every person is different with how he or she wants to wear the pump.
Okay, thank you, Erik. Now, a few questions regarding the outcomes. We already talked about the glucose metrics outcome, but one question is the acceptability of these systems, and Erik already talked about one key question, the number of dropouts. And as he mentioned, we had a very low number of patients that dropped out with the DBLHU coupled with the Roche Insight pump in Europe, with less than 1.5% dropout rate, which is very low. And we don't have these figures with the other systems, although we have some indirect evidence from Medtronic based upon some studies that were performed in my country. And I don't have the figures for the other systems. So what we want to know are the causes for this dropout. Is it a question of the algorithm or usability? So this will be very interesting to study in the near future. And the other key question is the patient-reported outcomes. Well, I must say that the most impressive data are probably related with what children and parents experience with closed-loop systems, because these parents are very improved with the safety of the closed-loop systems, which they can rely upon. And I've chosen this study because it shows that the poor sleepers among the parents became good sleepers thanks to an efficient closed-loop therapy system. So we probably can be confident that closed-loop improves the patient-reported outcomes in the pediatric field, but still we need some more data in the field of patients' distress among adult patients. So this will be a very interesting field to study in the near future. So what I want to show you to conclude my presentation today is a clinical case. And first clinical case is about a patient that became pregnant while being on the DBLHU closed-loop therapy. And if you look at this young patient that had a type 1 diabetes for 20 years, and she started gemelar pregnancy in February 2021. And here the outcome that was observed on open loop. This time she was on Omnipod and G6 sensor. And she was equipped with DBLHU for the third trimester of the pregnancy. And you can see the improvement in the time in range. Please be aware that the optimal range is different, obviously, during pregnancy. Please look at the time below range and the glucose management index that was significantly improved during this third trimester. And also look at the total insulin that was being used just before the cesarean section, 73 units. So she delivered on DBLG1 here at 4 in the morning. And you can see here the outcome during the labor time of this patient. And she delivered so a boy and a girl, both healthy, no need for intensive care, no hypo, and the weight of the two babies. And on the first week post-delivery on DBLG1, what we could observe is, despite a very good time in range, we had maybe 2 frequent hypos, and this was related with the average consumption of insulin, which dropped from 70 to less than 50 units per day. And this is an example of the need to adjust the settings according to the situation. So in this situation, you need to reduce the total daily dose in order to prevent the hypo. And the other examples that I want to finish with is a young patient that was equipped with a control IQ and which was very reluctant with a hypoglycemia. And this shows you that closed loop can do the best, but it can not do what it's not meant to do. And in other words, this patient was doing too frequent manual bolus because he insisted to be on very low glucose level. And it happened that all this frequent manual bolus ended up in a severe hypo here that you can see here. And this is an example of the way we could progress in the future. We hope so, in order to prevent this kind of event. Well, I thank you for your attention, and both Erik and I are ready to take any question.
I'm seeing the questions and answer. Do you want me to start answering them, Karen?
Yes, by all means, please do.
Okay. So do patients need to know how to carb count? Do they need to know? The answer is no, they don't need to. And that is true with the current version. It'll even be more true with the version rolling out later on this year, where the unannounced meal and meal management will be much more advanced. But even today, the reality is that there's a button at the bottom of the meal announcement that says small, medium, large. And the last time I checked, about 70% of meals were announced by small, medium, large, and then the system takes care of it. So that kind of takes care of the last question of, does the patient still need to be bolus dosing? The answer is no. You just declare the meal, then the system is going to propose a bolus, and in 93% of cases, the patient just accepts it and it goes. So you have a specific, of course, you have a wide variety of types of patients. Some patients always want to tweak. Many patients are just on a, let the system run and give me more time back for my life mode. And there's many of them that are like that. They're just small, medium, large, and then just accept and let the system run. Pierre-Yves, do you want to?
So the other questions, from the user perspective, the system will work the same way, whatever the pump is chosen. I have the experience of having used the system with 2 different pumps, and there are no differences regarding the functioning of the algorithm, whatever the pump will be used.
Yes. You could say that there may be, the main differences are more in cannulas, and for some specific people, different pumps usually have different cannulas, so it might work slightly better for some patients than for others, but in general, it doesn't really matter. Is it switchable between millimoles and milligrams? Absolutely. We currently have versions for Germany, for the Netherlands, that are validated in milligrams, and both milligrams and millimoles. How accurate can the algorithm be said, bearing in mind that we're relying on interstitial fluid rather than blood glucose? Now, more than that, we're still relying on a sensor, and be it the Dexcom sensor or the Abbott sensor, we all here know that they have their limitations. And there's 2 limitations. One is in the precision of the sensor itself, and also you have the lag of time. Now, the time lag is really quite limited. You're talking about 3 to 5 minutes between blood and interstitial. So that, in the grand scheme of things of managing diabetes, that doesn't really matter. It really only matters, let's say, if you have a lot of insulin stacking and all of a sudden you're going to go out running a lot, then you would have all your insulin flooding and a huge drop. But outside of that specific scenario, doesn't really matter. The precision itself, that's a limit. And that's why there are specific warnings around that. In general, of course, the Dexcom is precise. It has a good MARD. It is very rarely seriously off, but it's going to happen. And the patient, one of the limitations is that if the patient feels like he has a hypo, and the system's telling him he's at 120, he needs to check by hand. But that's the exact same limitation as wearing a Dexcom itself. The one thing that I will say, though, is that in general, we haven't done a proper clinical study on this, but most patients report an either recovered or an increased sense of hypoglycemia awareness within 1 to 3 months after starting wearing the system. And so that really helps protect, because when you decrease the variability of your blood glucose, actually within 3 to 8 weeks or so, you start seeing both hypoglycemia awareness, but also hyperglycemia awareness, the feeling of hyperglycemia. People report that before they would only feel the general diffuse sensation of hyperglycemia around 250 or so, for example. And after wearing the system for a while, they could start having the same feeling around 190 or something like that. Pierre-Yves, confirm that?
Yes. Well, regarding this question of sensors, I confirm that the awareness of the patients can change following the equipment with the closed loop, and it is really impressive within a few days or a few weeks. So this was really impressive, especially in patients with very uncontrolled diabetes. There was one question regarding the CGM that being used. I must say that patients are very satisfied when using the Dexcom sensors. We have no experience of any closed loop with the Freestyle Libre sensor, with the exception of some patients that are doing the do-it-yourself closed loop system, but I will not talk about this today. And a little bit less satisfaction with the Medtronic sensor. And this is what I can say to these questions. And there was another question regarding the pregnancy. Well, I'm sorry, I talked about pregnancy because I thought it was a very interesting story to tell, but regarding the CE marking of the systems, only one system is marked for pregnancy. So I don't have the right to say that we can use our system when the patient is pregnant. Although we had the experience of patients that were equipped with DBLHU and that became pregnant while on DBLHU, including during trials, and the recommendations from the monitoring board was to carry on using DBLHU during pregnancy because the glucose metrics were very good with this closed loop system. So this is all what I can say regarding pregnancy.
Yeah, and we're going to conduct a post-market clinical study to refer with all the pregnancies that have happened with DBLHU in order to include in the CE mark, again, probably at the latter end of 2023. The other question, what is the likelihood of going to DKA? Does the algorithm revert to a reset basal rate if it reaches the maximum bolus limit but cannot control blood sugars? The maximum bolus limit is actually quite high. It's dependent on the level of the glucose over the past few hours. Because obviously, for example, if you have the flu or some kind of steroid treatment, you're going to need significantly higher doses than usual, up to 2 or 3 times usual doses of insulin. And the system has limits that are built around, I'd say, the past few hours of glucose levels. So typically, we only have a few cases, but we don't have a proper clinical study in people running DBLHU with the flu, but you're going to have fairly elevated glucose levels, but that will kind of plateau between 190 and 220. And then the system's just going to send large amounts of insulin. Now, if the system is going high, the glucose is going high, despite large amounts of insulin being sent, above 300 for an hour or so, or 2 hours, then there will be an alarm that says, please check your infusion site, or have you eaten a large meal and not told the system, or is there something else weird happening? That's how we manage the increased glucose in order to decrease the DKAs. But so far, of course, on 10,000 patients over a year, we've had DKAs. All of them, and literally all of them, have been down to infusion set issues.
Now, there are 2 questions regarding the kind of reports that we can have with Diabeloop DBLHU. Well, the data are available on real time on a web-based platform, which is called Euroloops, so that we can have the usual reports in terms of time in range, time below range, etc. And you can define the period of time that you want to study, to analyze. For instance, if you want to study a period where you had made some specific tuning changes. And it's available on this platform, but it's not scheduled to be available on a Gluco platform. Will it be available for use in pediatrics in the future? Well, actually, we had performed a study in children age 6 to 12, and the study had been published this year in the Lancet. And we still depends upon regulatory authorizations. And Erik, I don't know if you have some information to
Yeah, I'm sure many of you have heard about the new European regulation called MDR, and our notified body actually was backed up and did not take up that. So we will reuse that study to extend the indication now that we have transitioned over to the MDR. But that was a bummer because really we did the clinical study, all the documentation was done, and it wasn't accepted, not because there was a problem, but because the notified body didn't have time to look at it. That was quite frustrating.
What about the availability of DBLHU in the UK?
That will come as soon as we finish the integration of the CAM-APS and the other pumps. So expect it sometime this year. I can't commit to a specific timeline because it will also depend on the final checks from regulatory, etc. And now there's a specific registration process in the UK now that it's no longer in Europe, but that's something that we're working on along with our friends at Dana and Suil. So that will be coming, but as fast as we can, honestly, sometime this year, but I can't really commit to a specific time. What other questions are missing?
Can I just ask you to confirm the name of the platform that it uses?
Euroloops. It's a proprietary platform that we use. It was derived originally from Tidepool, from the Tidepool platform. So many of you that use Tidepool will be recognizing quite a few features. Also, we've made it evolve on our side with specifically. There's quite a few doctors that wanted specific reports and ways to visualize and control times, et cetera. So we've made it evolve, but it's still visually quite close to Tidepool.
Thank you.
Well, there is one question from me. How is it different from CAM-APS? Well, both systems are modular systems and designed to be interoperable. And I cannot comment about the algorithm. And from the clinician perspective, I must say that there are no head-to-head comparisons of closed loop systems. So it's impossible to provide an accurate answer to this interesting question. But I think that my perspective is that we are lucky to have different systems available so that we can try to have one system fit to a particular requirement of a patient. So this is a good news, I think.
There's a question in the bottom. Is there a minimum specification to mobile phone to run the software? The answer is yes, and that is more linked to the version of Android or the version of iOS because of cybersecurity features. Android, below Android 10, the reality is that you really don't want someone be able to send a remote bolus because he hacked into your phone. That would be a nightmare scenario. And anything below Android 11 really doesn't cut it in terms of cybersecurity. And same for certain versions of iOS. But any of the latest phones, even I'd say entry-level latest phones, will be able to run those versions of Android or iOS. I mean, entry-level iOS, yeah, kind of doesn't exist, but anyways, you know what I mean. That's what it's really linked to.
There is a question regarding patients that experience a frequent DKA. Actually, we had another version of the algorithm, which is called DBLHU, and we designed this algorithm in order to more specifically tune the settings according to these very peculiar physiologies of these patients that had very abrupt deterioration of the glucose levels. And these patients were meant to have a pancreatic islet transplantation, so this gives you a picture of the severity of the diabetes. And we published these results showing that we had very nice outcomes in these patients that are still using the system. So I believe that a nicely tuned algorithm can address these difficult patients. And the history of DKA is not a contraindication to use of a closed-loop system.
And then the second part of the question, is there any scope to keep a patient on 50% dose of long-acting insulin? I mean, I don't recall any examples of anyone actually doing that. There may have been one patient in Germany that's doing that, but there's nothing that would prevent you. Let's say someone needs 40 units per day, to tell the system 30 units and then inject 10 units of long-acting. I mean, it would be weird, but if there's something really specific from a patient, I don't see why that would be a problem from an algorithm standpoint. It might be tricky from a usability standpoint because you really don't want a patient to forget to inject his long-acting or things like that, but I mean, why not? There's nothing that would prevent it. What about CYP who struggle to remember to bolus? That's an interesting one. First of all, we currently have a significant number of patients. I mean, the Diabeloop system currently already manages kind of unannounced meals. It doesn't manage them very well in the current version. We have a clinical study starting next week on adolescents who oftentimes do not want to announce their meals or have anything to do with their system really around lunch in particular. And so the whole idea is to do fully unannounced meals as optional, basically. Basically, the patient doesn't have to announce meal. Now, obviously, you're never going to have exactly the same performance if you don't announce meal, but you can be really pretty good, particularly if you use Lyumjev. The unannounced meal bit of algorithm plus Lyumjev works extremely well.
Yes, for clarification, Erik, you spoke about the integration with Danai Pump, and so some misunderstanding. Yes, you mentioned KMAPS. No, it's integration.
Did I?
Yes. Yeah.
I apologize. I meant Dana.
Yes, yes. Regarding the meal size, so once again, usually we can assess the average consumption of carbohydrate, for instance, for lunch, and say we have an average of 50 grams, and then we also estimate the lowest and the upper limit of this particular patient, and these three numbers are being entered into the system at initiation, so that we have a range of carbohydrates, so that it helps to decide average meal, small meal, or large meal.
Yeah. And the system, the algorithm kind of assumes that the patient will make a mistake, and even if he announces a meal very precisely, if he says 57 grams of carb, the system kind of assumes that there will be a mistake in counting, and so he will react dynamically on how the meal itself is going. So if the patient's glucose levels are increasing much faster and higher than usual, it will automatically start sending small compensation bolus even an hour after the meal or 30 minutes after the meal. And the opposite, if it's increasing much less than usual, then it's going to cut insulin during all the duration, the postprandial duration.
We have some real-life data regarding ultra-fast insulin, showing that without any particular settings of the algorithm, it works fine. We have not conducted clinical studies with ultra-fast insulin, but it is on only real-life data. We have some in silico data showing that it works very fine with new ultra-fast insulin, such as early Lyumjev.
And there's nothing, and the DBLHU system is indicated for fast-acting insulins, which actually Lyumjev and Fiasp are also labeled as fast-acting insulin. So it is actually indicated for even Lyumjev. There's nothing that prevents, even from a regulatory standpoint, the use of Lyumjev with DBLHU or Fiasp.
we don't need to tune the insulin duration of action.
No, you have the self-learning. The self-learning of the system takes care of that. How much average insulin dose is given in different types of meals roughly? Basically, so it doesn't depend on the nature of carbs, okay? Today, and we've done some experimenting, some clinical trials in the past with that. If you do, because the problem is that it's the nature of the carbs, it's not the order of the carbs. If you start with some white bread in the beginning of your meal, it doesn't going to be the same than if you eat that white bread at the end of the meal, and if your first part is heavy in fat, which is going to slow the digestion. So actually, it's very complicated to do perfect meal announcement. And our approach, rather than trying to let the person tune or enter specific details about the types of carbs, is just simplify it. Let the system run and react dynamically, rather than asking the patient to announce more specific things, which are difficult to train on, and even then, sometimes inaccurate.
So that the question is of Simon, I'm assuming that active insulin time is not relevant. Well, insulin on board is taken into account, obviously, by the algorithm, but the patient does not have to deal with it. It's automatic. The nature of the carb, I say that there is a specific feature we can tick on a box to precise that there is a fat-enriched meal. This is a very specific feature of this algorithm, because the bolus is not sent in one time. The bolus can be split in two parts, depending on the glucose level at the initiation of the meal, and depending on the presence of fat or not in this meal. So that the second part of the bolus will be sent either 30 minutes later, or 60 minutes, or up to 2 hours or 3 hours after the onset of the meal. So this is a very specific feature of this algorithm.
Yeah, our patients in Germany called that the pizza button. And also, over the next 10 hours after the meal, if the patient ticked the fat meal button, it's going to be, I'd say, looking for increases in glucose, because as most of you know, if you eat a pizza, you're going to have a somewhat delayed reaction initially, but then 4 to 6 hours after the meal, typically, or 6 to 8 hours after, you're going to have a rise in glucose when the end of digestion comes in. And so that's going to be taking care of that automatically. How soon after a bolus can the pump bolus again? Now, there's two different questions in there. The system, the Diabeloop system itself, DBLHU, can send boluses every 5 minutes. Now, every pump, now we work with multiple pumps, okay, and different pumps have different bolus speeds, and the Danai even has settable bolus speeds. And so there's not one answer to that one. You can always ask the system. I mean, the system is going to send small boluses every 5 minutes, large boluses every 10 minutes automatically. If you want to send it manually, that's going to be depending on the pumps, really.
Erik, do you mind if I ask just a technical question, because I know that a lot of the DSNs will ask us when we're out talking to them. So the current algorithm is sitting on a handset, is that correct? And you have plans to go to an app-based one. Will the handset be available? We have lots of situations in the UK where a handset would be really beneficial for the people, just down to costs and families not being able to afford mobile devices and things. There's been sort of a lot of positive feedback out there about the fact that you can have it on a handset. Will that continue even if the apps are available?
Yes, for 3 reasons. One is that, like you said, there's availability to have the right types of handsets. 2, actually, the French government has told us flat out, you're not going to get reimbursed unless everyone has the ability to use your system. You don't want to force people with type 1 diabetes to have to buy certain types of phones. And the third is that some patients, for example, have company phones. And on those company phones, they can't install certain types of apps. So regardless, you need to have the option to keep a dedicated handset, and that will continue in the future.
Brilliant. Thank you for that.
Thank you all so much. We have now run out of time, but a big thank you to Karen, Will, Pierre and Erik for delivering such an interesting webinar today. And I hope that we've managed to answer as many questions as we possibly can for you.